Hi, good afternoon, everyone, and thank you for joining this webinar. It looks like we still have a few folks trickling in, so hang tight for just a bit, and then we'll go ahead and get started. All right, well, we have a lot to cover today, and we want to make sure we have as much time for Q&A as possible. So let's go ahead and get started. Good afternoon, everyone, again, and welcome to ARCCA's learning session on Hope for Our Coast, Conserving California's Coastal Habitats in the Face of Sea Level Rise. This webinar is organized by the Alliance of Regional Collaboratives for Climate Adaptation, or ARCCA, in partnership with the Nature Conservancy. And my name is Julia Kim. I am a Senior Project Manager at the Local Government Commission. I also serve as the coordinator for ARCCA, and I will be your moderator for today's webinar. So a quick overview, I'll first provide a brief introduction to ARCCA for those of you who may not be familiar with us, and then we'll pass it on to our panelists for our feature presentation, and we'll also have a robust Q&A panel. Speaking of questions, I wanted to just go over some logistical items. So everyone will be muted except for our panelists, and due to the large number of participants, we ask that you type your question into the question box. This should be in your GoToWebinar control panel. I'll be summarizing questions during the Q&A panel portion, which will follow the presentation. So feel free to share questions at any point during the presentation, and I'll go ahead and summarize that for the Q&A discussion. And any questions that we're not able to get to, I'll work with our panelists to provide written responses after the webinar, and we'll share those responses in a follow-up email. And this webinar will also be recorded and made available on our website along with the presentation. So as I mentioned, this webinar is being organized by ARCCA, which is a network of leading regional collaboratives from across California that are working together to advance adaptation statewide and increase local capacity to build community resilience. So we do a lot of knowledge exchange. We also support emerging collaboratives, and we also serve as the primary channel with the state. And looking at our current membership, I haven't had a chance to properly update this map and include the new logos, but our membership now covers the North Coast, Sierra Nevada Mountains, the Capital Region, the San Francisco Bay Area, Central Coast, Los Angeles County, and San Diego County. I think since our last learning session, we had 3 new additions, so the North Coast Resource Partnership, the Bay Area Climate Adaptation Network, and the Central Coast Climate Collaborative. And we will be working in the Inland Empire region to help form a new collaborative later this year. The Governor's Office of Planning and Research serves as our state liaison, and we also have a number of affiliate members who are working statewide and at the national scale as well to advance adaptation. So it is my pleasure to introduce our panelists, our presenters today. First, we'll hear from Walter. Walter Hetty is the coastal marine ecologist for the California chapter of the Nature Conservancy. He provides the science needed by the Nature Conservancy and partners to meet conservation objectives at the land-sea interface. His work synthesizes our understanding of the ecological function and benefits to humans of coastal systems in order to improve the quantity and quality of these often imperiled habitats. Walter co-led work to inventory and classify the estuaries of California, Oregon, and Washington, and assess their nursery role for commercial and imperiled fishes. During his postdoctoral research at Moss Landing Marine Laboratories, he helped develop the California Rapid Assessment Method, or CRAM, for bar-built estuaries. Walter earned his PhD from the University of California, Santa Cruz, Ecology and Evolutionary Biology Department, and has over 2 decades of experience in marine, estuarine, freshwater, and terrestrial ecology, restoration, and conservation. Thank you, Walter, for being with us here today. And then we'll also hear from Alyssa. Alyssa Mann recently joined the Nature Conservancy as the Coastal Project Director in California. She focuses on developing and implementing strategies to protect the California coast and managing the Nature Conservancy's coastal climate adaptation demonstration projects. Current projects include restoring and revitalizing Ormond Beach in Oxnard, nature-based adaptation of Highway 1 at Elkhorn Slough in Monterey County, and developing sea level rise adaptation strategies for Point Mugu Naval Base and its surrounding wetlands. Prior to joining the Nature Conservancy, Alyssa worked at the Sea Grant program at the University of Southern California, where she focused on planning for climate change impacts along the coast and building community resilience. Her background is in emergency management and international affairs, having worked at multiple federal and state government agencies, including FEMA, the U.S. Department of State, as well as the state of California. So thank you both for joining us today. And with that, I will pass it over to you, Walter.
Okay, thanks Julia, and hi all. My name is Walter Heddy. I'm the Coastal Marine Ecologist for the California chapter of the Nature Conservancy. And I am pleased to present to you a high-level summary of our vulnerability and conservation assessment of California's coastal habitats, titled Conserving California's Coastal Habitats, A Legacy and a Future with Sea Level Rise. This work was conducted in close collaboration with the California State Coastal Conservancy. Before I get started, I'd like to show an outline of today's presentation. In this presentation, I will summarize the assessment, describe our vulnerability framework, highlight vulnerability results, and discuss our 5 mapped and quantified strategies. This assessment was driven by a fundamental question. Can we maintain the current extent and regional composition of our coastal habitats in the face of sea level rise and other stressors? This assessment sought to answer that question and provide information and tools to guide the conservation and adaptation actions of our 2 organizations and partners like yourselves. To answer this question, we developed a method to assess the vulnerability of coastal habitats to sea level rise. We applied it to the entire 3,500-mile California coast from Oregon to Mexico, including the San Francisco Bay Area. We conducted this assessment in 3 steps. First, we characterized the coast of today. For this part of the study area extends from mean lower low water to 5 miles inland beyond the furthest extent of 5 feet of sea level rise. We did this because we wanted to understand the impacts of sea level rise in a landscape conservation context, to see how impacts may increase patchiness and habitat isolation, and what was needed to avoid this and maintain a well-connected mosaic of habitats and conservation lands. We characterized the coast in terms of biodiversity and land use. For biodiversity, we characterized the coast in terms of 40 different wetland and terrestrial habitat types. We also looked at the records for 159 imperiled species, and we also looked at the records of 3 marine mammal and 3 shorebird species use of our coastal habitats as critical habitat and haulouts, which are critical for these populations' reproduction and maintenance of these populations. For non-habitat areas, we characterized land use in terms of 17 different built environment categories. This includes 3 different types of agriculture. Over all of this, we characterize the conservation management status and ownership of the lands. Second, we developed a sea level rise habitat vulnerability assessment. For this section, our analytic zone was a smaller area than that larger study area, a smaller area of inference for the impacts to tidal and terrestrial habitats from sea level rise. We used NOAA sea level rise data because it was available statewide, and we assessed 2 feet and 5 feet of sea level rise. For each of our 40 habitats, we quantified and mapped habitat vulnerability. We combined results and data to identify 5 strategies to conserve our coastal habitats in the face of sea level rise and other stressors. We quantified and mapped these strategies, and this enabled us to provide statewide and regional prioritization with high resolution local detail. And this slide here shows what that high resolution local detail looks like. In the upper right-hand corner are the categories of habitat that are found within this screen grab. In the lower right-hand corner are the categories of built environment groups that are found within this screenshot for El Cerrito and the East Bay area. This just shows the high resolution of both habitat and built environment data. And it also goes to show that we use 1 square kilometer hexagonal analytic units for our study, because much of our data were very disparate, ranging from counts to linear measurements to area. And this also allowed us to make our calculations in a standardized replicated unit across all 20,000 analytic units of our study area. We also characterize sea level rise into subtidal and intertidal exposure separately. Here in this figure, we have intertidal waters in dark blue and subtidal waters in light blue for Elkhorn Slough, which is in the center of the Monterey Bay in Central California. The left-hand panel shows current conditions, the central panel shows 2 feet of sea level rise, and the right-hand panel shows 5 feet of sea level rise. We characterize sea level rise into subtidal and intertidal exposure separately because these two are very, very different, and each have important implications for habitats. This allowed us to track, for example, the area of intertidal exposure through time. And as we know, some habitats actually require intertidal exposure, where other habitats cannot take any amount of exposure to salt water, let alone once to twice daily, as we have in our tides in California. So we can watch the dark blue area of intertidal habitat or intertidal exposure actually in this panel, in Elkhorn Slough in the center of the panel, actually decreases with time. Now, Elkhorn Slough is one of the most well-conserved estuaries in all of California. This is not due to built environment or infrastructure blocking that tidal flow, but due to topography. And this was a little bit of an eye-opener and helped us realize that we needed to incorporate topography into our analytic framework, which we did. And this also allows us to track whether that area is increasing or decreasing for a given habitats, as it's decreasing in the main stem here. Also allows us to highlight what we call these bright spots. As you can see to the north and south of Elkhorn Slough, there's actually an increasing area of dark blue intertidal exposure. Oftentimes these are non-habitat areas and provide important potential as future habitat. We took our adaptation framework from an IPCC framework, looking at vulnerability as the relationship between potential impact and adaptive capacity. Now remember, this assessment is an spatially explicit quantification of vulnerability. And so for each habitat, we calculated vulnerability as the area of exposure for subtidal and intertidal exposure separately times the sensitivity of that habitat to that exposure. And sensitivity will range from 0 to 10, with 0 being no potential impact and 10 being the most extreme potential impact from that exposure. So you can imagine our lower intertidal habitats would have relatively low sensitivity to intertidal exposure. Our high intertidal habitats would have a moderate sensitivity to intertidal exposure, and our terrestrial and freshwater habitats would have the most extreme, or 10, sensitivity to intertidal exposure, meaning they would be greatly impacted by being touched by ocean waters. All habitats had the highest sensitivity to subtidal exposure as it was transferred to open water. We balanced this potential impact with adaptive capacity as the area available for each habitat to move into inland in response to rising seas. And this just followed a suite of simple rules that the habitats were excluded from the built environment, so we only looked at available habitat area for them to move into, and they were not allowed to transgress or move downslope or into themselves. So we calculated the area of habitat available to them upslope to balance this potential impact. Again, we calculated vulnerability for each habitat independently. So for in this panel, we can calculate the vulnerability scores for the habitats that were shown in this analytic unit, as shown here on the right, color-coded by the vulnerability scores. The vulnerabilities then range from 0 to 2, with 0 being there's no potential impact and therefore 0 vulnerability. And as soon as you move away from 0, there is a slight increase in vulnerability and a continuous number all the way up to 2. You see in the upper right-hand panel of your screen here. And these habitats that have a vulnerability of 2 have no adaptive capacity. These habitats actually have their back against a wall, whether that's topography or the built environment. They have nowhere to move in response to rising seas. Again, there's a continuous range of vulnerability between 0 and 2. I'd like to train your eyes to that horizontal dark line in the middle of our vulnerability scale, which is more or less the 1-to-1 ratio, where a habitat will have as much room to move into as it has potential impact that it might experience. And we'll follow this line throughout the rest of this talk. So we calculated vulnerability for each habitat individually, and then we also calculated a vulnerability index score, which was the area weighted average for all the vulnerabilities within a given analytic unit. And that's what I'm showing in this series of maps here. We have the north coast on the left hand, central coast in the center, and south coast in the right hand panels. Again, our vulnerability legend is on the right. And there's a few takeaways from this figure that I'd like you each to take away. First of all, it's very hard to represent 3,500 miles of linear coast in California in one PowerPoint slide. However, our maps are really high resolution. And so if you're interested in a given region or even a given site, you can zoom into these areas, into your area of interest, and find the details for all of our different results and data categories, whether it's vulnerability, habitat, or what have you, as I showed through these this PowerPoint. And those maps are available in high resolution within our report, as well as via our website. The second thing to take away from this is that you'll probably quickly see that there's a lot of orange and red in these maps. There's a lot of high vulnerability habitats in our coast. And in fact, from a habitat specific vulnerability, 59% of the area of California's coastal habitats are highly vulnerable to 5 feet of sea level rise. That's a grim result. And so let's look at some of the habitat specific results specifically. So I'm going to show you a series of habitats, and we're going to start with Upper Beach. Upper Beach, or a dry or towel beach, you might consider it. And for each of these, I'm going to show you maps on the left, again, with the north coast in the left-hand panel, central coast in the middle, and south coast in the right-hand panel. On the upper right are our bar graphs. The lower right is your vulnerability legend of the different colors. And the bar graphs have area in square kilometers in the y-axis. So each bar, whether it's the north coast, San Francisco Bay Delta, central coast, or south coast, is the total area of that habitat within that ecoregion. And they're color coded by the different vulnerability scores within that ecoregion. So as we can see, for our upper beaches are actually quite vulnerable. 76% of upper beaches statewide are above this 1-to-1 line. They have more potential impact than they do adaptive capacity and are considered highly vulnerable. And as you can see, that pattern is shared across ecoregions. So we're going to move to our wetland habitats. I want to keep your eye on the y-axis here. You'll notice a couple things. One, as we move into regularly flooded estuarine marsh, these are your salt marshes or your typical estuarine marshes, is that there's orders of magnitude more area of our salt marshes throughout the state than there were of our upper beaches. And you'll also notice that there's orders of magnitude more within San Francisco Bay Delta than in the outer coast ecoregions combined. This is true for our estuarine habitats at large. San Francisco Bay Delta is an incredibly important ecoregion for estuarine habitats, as you might expect. And then again, unfortunately, you can see that 58% of our regular flooded estuarine marsh are above that 1-to-1 line, meaning they have more potential impact than they have adaptive capacity and are therefore highly vulnerable. I'm going to show you one more habitat specific result here, and that is for our irregularly flooded estuarine marsh. Now these are your, they can be either transitional or high marshes, which will be fringing your regularly flooded estuarine marsh, particularly within the San Francisco Bay Delta. Or on the outer coast, these might be the dominant marsh type for the many bar-built or seasonally closed estuaries that are common throughout California. And in Southern California are the dominant estuary type, and therefore that's the dominant estuarine marsh habitat type as well. And so a very interesting takeaway from this is that unlike any other estuarine marsh habitat, there's as much of this irregularly flooded estuarine marsh in the south coast as there is in the San Francisco Bay. And then unfortunately, you can see for Southern California, 59% of irregularly flooded estuarine marsh, which is a really critically important habitat for that ecoregion, are also highly vulnerable. Okay, there might be other habitats that you might be interested. In this panel, we have, again, area in square kilometers along the y-axis. And across the top, we have our different ecoregions. North coast on the left, San Francisco Bay Delta next, central coast to the right, and on the far right is our south coast. Within each of those ecoregions, we have 8 different habitat types. And what we did to simplify in this presentation, rather than present all 40 habitats, I'm presenting 8 focal habitats. From the left to right, there are 6 habitats that are only found along the land-sea interface. There are 3 outer coast intertidal marine habitats, Rocky Intertidal, Swash Beach, and Upper Beach. And there are 3 estuarine intertidal, Tidal Flat and Salt Pan, regularly flooded estuarine marsh, and irregularly flooded estuarine marsh. Next, we lumped all 8 freshwater habitat types into one freshwater class, and we lumped all 18 terrestrial classes into one terrestrial habitat category. For each focal habitat, we are looking at the total area in that bar within that ecoregion. And then within each bar, we have above that 1-to-1 line colored in red is the highly vulnerable, and below that 1-to-1 vulnerability score is in green of being less vulnerable. And as you can see, that pattern of a majority of area having high vulnerability holds true for most habitats in most ecoregions. This has cascading impacts to the many rare, threatened, and endangered species that rely on these coastal habitats. Now, I'm going to divide these areas in red and these areas in green into whether or not they are conserved or non-conserved for each of these areas. Okay, now we have in dark red, vulnerable non-conserved lands, in pink, vulnerable conserved lands, in bright green or chartreuse, we have resilient non-conserved lands, and in dark green, we have resilient conserved. And then furthermore, looking at the conservation management status, we can calculate that 41,000 acres of coastal conservation lands are projected to be drowned by subtidal waters. So now, using the information in these bar charts, we have the basic information needed to guide conservation management and adaptation to maintain habitat area and composition in the face of sea level rise and other stressors. And we've mapped those habitat categories in what we call our strategy map, where every square inch of our study area is colored with habitat and management status information, and every square inch of the analytic zone is colored with one of these 6 data categories, each with an associated strategy. They are organized into 2 larger themes: conserve and manage for resilience, and mitigate potential losses of vulnerable habitats. Now I'll go through each of these strategies with you now. First, in dark green, we have our resilient conserved lands. Maintaining resilient conservation lands, meaning maintaining the conservation status of the landscape, as well as taking management steps to ensure that coastal habitats remain resilient to sea level rise. Each ecoregion contains extensive networks of resilient conserved lands, which should be managed to preserve natural coastal processes, resilient habitats, and the goods and services they provide to people. In bright chartreuse or bright green are the resilient non-conserved lands. These are our bright spots, opportunities to invest in conserving resilient strongholds, providing opportunities to more than double the overall area of protected resilient coastal landscapes statewide. Investing in the conservation of resilient strongholds will allow natural coastal processes to be maintained, including the movement and transition of habitats in response to sea level rise, and will enhance the resilience of other coastal areas. This will be important for all habitats, but critical for habitats that may not be able to accrete sediments to adapt vertically, such as rock intertidal, some beaches, irregularly flooded estuarine marsh, and terrestrial habitats. In pink are vulnerable conserved habitats. Many patches of coastal habitats will not be able to move inland in response to sea level rise due to topography or the built environment. Often the very habitats that lack areas to move inland also lack a sufficient sediment supply and delivery to enable them to accrete vertically to keep pace with rising seas. Managers can assist these vulnerable habitats by managing in place for resilience through sediment augmentation or sediment placement. This also may mean addressing human-made features or practices that impact water or sediment transport to restore natural processes in estuaries and coasts. This will be critical for estuarine marshes, tidal flats, and beaches. We will also need to mitigate conserved and non-conserved habitat losses from sea level rise. To be clear, the mapped pink and red areas are not projected losses, but highlight areas of potential loss. This highlights the importance of managing at a regional scale. While we may lose habitat in one site, we may be able to gain habitat area in another. We should work to maintain habitat area and composition at a regional scale. An important manner of mitigating habitat losses is to invest in potential future habitat. We identified areas with minimal development, for example, developed open space and agriculture, that are projected to be inundated by sea level rise or are adjacent to vulnerable habitats as opportunities for conserving potential future habitat. While generally a small proportion of these human and land uses, they provide significant opportunities in each ecoregion to increase habitat transition areas. Statewide, there are close to 200 square kilometers, which alone would mitigate over half the habitat losses from subtidal inundation. In urban areas, the built environment, including roads and other infrastructure, creates barriers that prevent coastal habitats from moving inland. Many of these built structures are themselves also vulnerable to sea level rise. We need to simultaneously protect human community assets and enhance the extent and resilience of coastal habitats by managing our infrastructure with natural processes in mind. This will be critical to maintaining habitat area and function and will also provide benefits to people. Using coastal habitats as natural infrastructure to protect the built environment provides other valuable co-benefits, such as improving water quality, sequestering carbon, enhancing fisheries, and providing recreation. As sea levels rise, California's coast will erode and evolve, and habitats will need to shift. The legacy of land conservation along California's coast allows for some habitats to move inland. Our current conservation efforts and land use management decisions must focus on further supporting these natural processes and enabling the transition and movement of coastal habitats as sea levels rise. We need to act today to conserve the extent, diversity, accessibility, and value of California's coastal habitats for future generations. Our results suggest that no net loss in the face of sea level rise and other stressors is possible, but will require significant commitment and investment in each of the 5 strategies. I'm presenting here a URL to access the coastal assessment report and my email address if anybody has any questions. And with that, I will hand over control to Alyssa to take it from here.
Thanks, Walter. All right, let me make sure I can advance the slides. Oh. Walter, doesn't look like I have control yet. Oh, there we go. All right. Well, good afternoon, everyone. I'm Alyssa Mann, Coastal Project Director for the California chapter of TNC. I'm going to tell you a little bit more about what we're doing with the results of this assessment to inform our decisions here to help guide our conservation actions. I'm also going to tell you about Hope for the Coast, our statewide campaign and vision for our future coast, and how we're working with partners across the state to advance conservation of our precious coastal habitats and advance adaptation planning so that it considers resilience of these habitats. Californians love their incredible coastline and have voted again and again to protect it. They did so again in June with the passage of Proposition 68. Because of this commitment, over 1/3 of our coastline is conserved, protecting incredible habitat and more than 150 rare, threatened, and endangered species. But with 5 feet of sea level rise, the coast of tomorrow will not look like the coast of today. As Walter said in his presentation, 59% of coastal habitat across the coast is vulnerable, including over 41,000 acres of conserved land that is projected to be submerged with 5 feet of sea level rise. So in other words, the very investments in conservation that we've collectively made over the years are under threat. But there is hope. With sustained coordinated effort, this study shows that we can have as much or more coastal habitat with 5 feet of sea level rise as we have today, ensuring that future generations can enjoy the remarkable benefits provided by the coast. Here at TNC, we're using the coastal assessment to help strategically identify the critical places in California where we and our partners need to invest in non-conserved lands that are currently resilient, and to identify those opportunities to protect potential future habitat so that vulnerable habitats have the room they need to migrate as sea levels rise. We are also helping support our partners as they are adapting the built environment. For example, we're working with Caltrans and the Alliance of Monterey Bay Area Governments to identify sea level rise adaptation approaches for Highway 1 in Elkhorn Slough that can achieve multiple goals: improve transportation safety and efficiency, promote healthy coastal habitats, and provide economic security and benefits to the local community. Projects like this one make sure that our coastal habitats are part of these conversations that are happening across our communities to address vulnerabilities to our infrastructure and our communities. But our actions alone won't be enough, won't be close to enough. It will require collective science-driven action at local, state, and federal levels, utilizing all of the financial and real estate tools at our disposal in furtherance of this unified objective, and considering natural habitats and the values they provide in development and infrastructure planning and decision-making. That is why we at TNC have put forth the Hope for the Coast vision for California. We need all California's coastal decision makers, state and local, to adopt this vision and make specific, meaningful commitments to advance it. We need state agencies, cities, and counties and other partners working to advance adaptation along the entire coast to align their decisions and financial investments towards a goal of achieving no net loss of natural coastline with sea level rise. So far, this campaign has galvanized California's coastal and ocean leaders and given them a vision of the future of California's coastline to rally around. Since the release of the coastal assessment, the Ocean Protection Council and the California Coastal Commission have formally approved resolutions adopting this vision and making specific, meaningful commitments to advance it. The State Lands Commission and the State Coastal Conservancy have placed similar visions on their agenda and anticipate adopting them shortly. A number of local governments are considering similar resolutions as well, and other partners from federal, state, and local entities are also supportive and reached out to us to find out how they can participate as well. And that includes the Central Coast Climate Collaborative that just put forth a support letter detailing their commitments and contributions to this vision. In September, California will host the Global Climate Action Summit, at which leaders from around the world will be asked to make strong commitments to combat and adapt to climate change. We anticipate this shared vision will be announced at the plenary event at the summit. We continue to look for strong partners to advance this effort. Please follow up with me or Sarah Newkirk if your organization would be willing to provide a support letter detailing your contributions to this vision, or you can help bring a resolution to your city or county. With that, I want to thank LGC and ARCCA for hosting this webinar, and we look forward to your questions.
Great. Thanks so much, Alyssa, and thanks, Walter. A reminder to all of our participants who are joining us today, please keep those questions coming. You can access the questions panel in your control panel and just go ahead and type it in. I'll go ahead and summarize it and share it verbally with Walter and Alyssa. So we do have a few questions coming in. One asking, were contaminated lands considered in sensitivity and vulnerability analysis?
That's a great question, and that can take that and then expand upon it a little more broadly. So the specific answer is no. We did not consider contamination or some of these other impacts in terms of the sensitivity or the vulnerability. What we did is we used the extent of the habitat, and we actually quantified the sensitivity of that habitat was whether or not whether or not it was facilitated by being inundated by intertidal waters or impacted by being inundated. And the way we calculated that was we took the total area of that habitat statewide and looked at the proportion of that was within current tidal area. And then we took that proportion and related it mathematically to our sensitivity score. So it was very much simply related to intertidal exposure and the probability that that exposure would impact that habitat. To expand upon that question and answer, we did not consider pollutants or other stressors, and we did not really consider other measures of condition, quote unquote, of given habitats.
Great, thanks, Walter. And then we have another question. How does the no net loss of habitat differentiate between overall total habitat and habitat diversity given future conditions?
Yeah, it's another great question. So what we're thinking, the framework in which we're considering quote unquote no net loss is thinking about it statewide or at a regional scale. And in my opinion, it really comes down to a regional scale of management. So the idea is that we understand that there will be areas, and we're not promoting the conservation of a given blade of grass or a given branch of pickleweed, for example. We know that there will be losses of a given habitat type in some spots. But if we step back at a regional scale and really consider these losses of specific habitat types and consider these opportunities with potential future habitat to make up for those losses, the idea here is that, in my opinion, at a regional scale, we should be able to maintain habitat area on a habitat by habitat basis and habitat composition, speaking to the other part of that question, meaning maintaining the diversity and relative abundances of these different types of habitats at a regional scale, which should scale up to a statewide maintenance of no net loss.
Wonderful. We have another question here. There's a great initiative. Can you clarify the 5 strategies and the role of habitat retreat in aligning not just conservation land purchases, but other land use and development decisions with accommodating the inland retreat of vulnerable habitats? For example, does the plan discuss or are you working with government to incorporate the results into land use or zoning decisions?
Wow. Let me see if I can work through that one. The idea here is straight on the spot with the way the question was asked, in that the idea is the ability for each habitat type to move inland. And if we think about that as a series of habitats which have very narrow elevation and elevation bands for which they're adapted to, and other either intertidal exposure, moisture, in all these different habitat gradients that they're adapted to, there's going to be very specific areas projected in the future that they will be able to move into. And if you think about that very simplistically as a sequential movement of each of these habitats inland, is there enough room for each of these habitats, including terrestrial habitats, to get out of the way of wetland habitats as they move inland? That's the framework, and so it's on a habitat by habitat specific basis. However, the vulnerability index takes all those into account for more of a landscape context. If you're not really focused on a habitat specific basis, you can look at the vulnerability or resilience of nature to maintain itself in the face of sea level rise. And that actually becomes pretty important when we're thinking about organismal use of the landscape. For example, elephant seals don't actually only roost or haul out on beaches. They use beaches, dunes. We've seen them in willow forests, which are become dunes after the elephant seal is there. And so it's really important for those regards, or for important bird areas that have been mapped throughout the state, for example. In terms of how we're using it, I think that's a great question, and I encourage folks to use it in that regard and to think about how it plays into zoning and land use and management decisions. And we're working with local governments and other agencies. And I don't know if Alyssa, if you have anything to add to that?
Yeah, sure. I'll jump in here. And, one of the things as we're going around the state talking to local, regional, and state officials is to brainstorm together about the ways to use this data or other local information that's available to integrate it into things like local coastal program updates or general plan updates and those types of activities. I think right now we're at sort of the stage of figuring out how to support those activities and what, as we're talking to folks about the different types of commitments that they can make, and one of those is really just to utilize this data set as they're doing a lot of this planning. And so we're looking at those opportunities to help kind of facilitate that use.
And Julie, I have a little bit more to add to that one. Is the habitat specific data really facilitates that kind of investigation. And then the other thing to think about is that the built environment character categories are pretty broad. Pretty detailed as well. And I've spoken with a few counties and some other local groups at this level, thinking about what potential impacts are you up against? What habitats are highly vulnerable within your county or within your region? And what strategies might we think about to apply for those habitats specifically? Then the other thing we can think about, one other thing we measured is what are the land use categories within those vulnerable analytic units that are really driving that vulnerability, meaning interrupting the adaptive capacity of those habitats, and what are the adaptation strategies for that site or for that region. And then the last piece is just really thinking about those details of the built environment categories. For example, in some counties, there might be a large area of undeveloped or minimally developed open space. And these are oftentimes your barren fields of weeds and open dirt. And the idea here would be to not develop those and consider the critical importance that those kind of barren lots might play in providing potential habitat into the future for, because we did not characterize those as habitat per se. And this would be an area to allow these habitats to transgress into in response to rising seas.
Thank you. A few more questions here. Do you know if there's a similar assessment that's been done or underway for more inland or montane habitats in the face of wildfire risk? I ask because it would be great to have assessments done for the whole state so that we can coordinate our funding and get a better sense of timing for investment.
Wow. That's a great sentiment, and I completely agree that it would be great to have this done statewide. I'm not aware specifically to that itself. I know that some of our scientists within the California chapter of the Nature Conservancy are working on forest management and also working in fire management, and also working for some other folks in the audience here of interest on climate impacts and climate adaptation, as well as kind of water and water use issues. So I know that there's some great science being done outside of this, and I don't have a better answer to that per se, but I do agree with you that the more that we can connect these different pieces, the better able we will be to manage our resources and indeed fund them and coordinate them. And that's, maybe, I don't know if Alyssa has something to add to it, that's bring it back to within the coastal zone and thinking of sea level rise impacts and sea level rise adaptation. That's also the higher message here, not necessarily, going inland per se, but really it's thinking along that thin band, north and south and into the estuaries and throughout the San Francisco Bay, that it really requires collective action and collective organization to achieve this goal of no net loss in the face of sea level rise and other stressors.
Great. Thank you, Walter. Another question for you both. Did your assessment take parks and public access to the coast into consideration for adaptive capacity?
Yes, it did. So the conservation management status was looking at a number of different categories of what the management status of those lands were from conservation, ranging from the topmost being, say, like a wilderness area, which is really managed for wilderness conditions. Next would be it's conserved and really managing for nature, but allowing some recreation and maybe even some types of extraction, And then it would be publicly owned, but not managing for nature or wilderness values, and then it would be privately owned. So that's the quick answer there. And we have pretty good resolution spatially and categorically on those data, as well as who are the managers and who are the key partners and stakeholders of those different categories to engage by geography. The other thing that we did do, and this is part of the report, is look at access and how vulnerability of our coastal habitats affects our recreation and coastal access opportunities throughout the state. And that was a distinct component of the assessment. So you can see that in the report.
Great. We have a few more questions, and I want to get a question from myself in as well. So through ARCCA, we've been working a little bit over the past few years to try to enhance urban-rural collaboration. As you noted, we really need collective action to be effective in our response efforts. And as you both already know, and I think all of our participants know, with the growing impacts of climate change, local and state agencies and really all stakeholders, their attention is kind of spread between all these different priorities and different impact areas. So, we really need to get buy-in and support and coordinate with our urban partners. Do you have any suggestions for how we can build a stronger case to do that? And I don't know if you have any specific examples you can kind of draw on from getting various agencies to sign on to the Hofer Coast Vision.
You want to take the first of this, Alyssa?
I'm thinking about it. That's a really good question. I think, we've been struggling with some of the same efforts here. Obviously we're a big organization, and trying to connect across the different kind of issue areas that we focus on is one piece, as well as looking at how these things intersect. I don't have a miracle answer to this. I think in this case we're really lucky that there's a lot of rallying around this upcoming event in San Francisco, and really aligned well with what we were seeking to achieve through this. I would think that what we're trying to do on the coastal program is really think a little bit more holistically about coastal challenges and more inland flooding challenges. And so that's kind of where our program is starting to head, is to look at those opportunities to look at adaptation in terms of floodplains as well as coastal. So I think we're all kind of learning at the same time, and we'll look to you guys as well through your programs on the regional scale to figure out how best to scale some of these kind of demonstration projects and get at some of those more holistic questions. But yeah, Walter, do you have any thoughts to this one?
Yeah, thanks for that question, Julia. I think, as the vision states, the idea is really the importance of collective and concerted action across geographies and across agency types from local through county, state, and federal. And one thing that I think this assessment provides is that statewide platform, right? So this is consistent methodology from site to site, region to region throughout the state, and that provides the platform to really provide the science-driven information necessary to come together around this vision and around this goal of maintaining no net loss in the face of sea level rise and other stressors. And the other thing I would add to that is that, the science really shows that it's, one big question that people ask is, where's the most important spot, or where do we really need to focus action? And, of course, I'm a scientist, and my answer is, it's all important. I'm a conservation biologist. It's all important. And I think one real important finding from this assessment is that, that's true. Each geography has important contributions, both in terms of habitat, as well as each of the 5 strategies. And that was a really important finding across this entire state. So, for example, in our more urban areas, there are still habitats there, whether it's the Bay Area or the South Coast. And those geographies are critically important in maintaining them, in adapting the built environment to allow those habitats to move inland, and also into mitigating potential losses through investing in potential future habitat. So I think that interaction between the urban and rural interface is importantly true in this assessment, and that we need to double down our investments within the urban environment as well as across the more rural and wild environments as well.
Wonderful. We have a few more questions. Let's see if we can get through these. So this might be a quick one. Are you still planning to make your maps interactive? And if so, what is your timeline?
Yes, thanks for asking that question. So we're still planning to work on making that interactive. And oh goodness, the timeline. If you have specific questions to that, please feel free to follow up with me. I'm hoping that we'll be working on that in the next few months or this calendar year. We've been working on some other fronts as well. And go ahead and visit the website and see if those high resolution maps can meet your purposes. Otherwise, please contact me to work towards interactive maps or accessing the geodata.
Wonderful. So in regards to the conservation of wetlands, are there any new or emerging wetland conservation strategies that could possibly preclude or delay inland transgression?
Hold on a second. I got confused with that question. Are there any new or emerging wetland management strategies that would prevent them from moving inland? Was that the sentiment of it?
Yeah, that would, yeah. Are there any new or emerging wetland conservation strategies that could possibly preclude or delay inland transgression? Yep.
None come to the front of mind. I can think about that more and follow up with that person following this webinar.
Sounds Great. And we have another question here. Can you summarize what is going on with the Pacific Highway 1 pilot project you mentioned?
Sure. We have been working for some time in the Elkhorn Slough area specifically, and really thinking about, we touched down there because we're looking at the vulnerability of coastal habitats, as well as the vulnerability of road infrastructure, thinking about the fact that a lot of what inhibit inland migration for coastal habitats is road infrastructure. And it came to bear that Elkhorn Slough is a really important geography for both of those two factors. We partnered and worked with a number of local agencies, as well as Caltrans and other local partners, and are currently engaging with local transportation agencies and Caltrans and looking at the vulnerability of the road infrastructure and how different adaptation frameworks might benefit both the resilience of that road infrastructure for human use, as well as how those impact or benefit the coastal habitats in Elkhorn Slough, being one of them, a very important estuary habitat for a number of different species.
And to add a little bit more on that, we got the AMBAG got a grant from SB1, and we're working jointly with them, and we'll be launching that project in the next few months. So hope to come to you guys perhaps next year with some early information about that study.
Yeah, and this is a really exciting project. And to me, one of the most exciting aspects of it is how excited these transportation agencies are about this. And this is really not only trying to help manage for our natural habitats in there, but really helping reshape how we manage and adapt our road infrastructure. And I know there's a number of people in the audience that are working on similar projects throughout the state, whether it's Scott Creek here locally for me is another project that's working. I know there's other ones in Southern California and San Diego that are happening, as well as up in the Humboldt area. And so to me, this is really exciting that we're gaining momentum and rethinking how this management and adaptation of our road infrastructure is done, and working to really help maximize and maintain and restore our coastal habitats, and in the hopes that maybe enhancing the resilience of these habitats and the road infrastructure at the same time.
Fantastic. And those are all the questions we have received. Last call for additional questions. Please get those in. And if we don't see anything, maybe I'll pass it over to you two for just some final thoughts and any kind of calls to action. I know, Alyssa, you already shared a couple calls to action. Before you do that, I have a quick question. So with the incoming, for the new administration in California, what would be your message to them to make sure that they're thinking about habitat conservation, they're thinking about sea level rise as they're starting their new term?
The new state administration that will eventually, okay, make sure we're clear on that. Yeah, I mean, I think what's really valuable about California is the kind of network of practitioners that are, really trying to be creative and innovative and pilot some of these kind of on the ground demonstration projects. And, I think the challenge will be to figure out how to scale those and transfer them to other places. And I think, being able to kind of maximize on the sort of the learning that we've already done and to be able to transfer some of those lessons will be really critical in this sort of next stage of adaptation. Just the example of the Caltrans work, knowing that other folks are doing, embarking on similar projects and being able to, share our lessons along the way and figure out how these different pilot projects can be done or replicated in a different way in a different place will be really key to getting at this big problem that we have about being able to maintain the existing habitat that we currently have, possible, but it's just going to take a lot of kind of collective effort, like we said. So, and again, I will likely, just so you know, I may reach out to a number of you to discuss opportunities for this campaign, but please don't hesitate to contact any of us because we'd really like to work with a number of you or all of you if possible.
Great, thanks, Alyssa. And Walter, it looks like there's actually one more final question for you. If sea level rise deepens a lagoon, how do you calculate that impact?
I didn't hear the first part. Sorry, Julia, what was that?
If sea level rise deepens a lagoon, how do you calculate that impact?
That's an interesting question. So to be clear, for this assessment, we did not assess subtidal habitats, right? So we didn't think about the impacts to the open water habitats, and there are a number of important open water habitats that need to be and should be investigated in terms of the sea level rise impacts, seagrass beds and other important subtidal habitats. In terms of the effect of deepening a lagoon, that's, you know, our barbelled estuaries, our seasonally closed estuaries are really complex systems, and how they will respond to sea level rise is a really challenging question. And whether they will deepen or not is, in my opinion, an unknown. You know, they might, the bottom of that lagoon might also elevate as sea level rise, depending upon sediment load. There's a number of really good work done at a number of different scales, including some work to adapt the sea level rise affecting marsh model to be used in barbelled estuaries. So you can look into that. Is a good resource there.
Great, thanks, Walter. And Walter, any final thoughts for our participants or any messages that you're hoping we can carry forward to the next administration?
Yeah, I did a little bit of thinking about that. I think we covered it pretty well in this presentation, but to me, I think it's California's done a great job so far, and that was really an important sentiment in our report. And I think we need to leverage that legacy of conservation and best management of our natural resources throughout the state and along our coast. And there's going to be a very severe and big challenge to maintaining our natural open spaces and our natural habitats in the face of sea level rise and other stressors. And in my opinion, it's been hard to maintain them even without sea level rise. And so for many, it's daunting to think about doing it in the face of sea level rise. The big stepping back, of course, natural habitats are able to adapt to sea level rise. Whether or not they'll be able to keep pace with accelerated sea level rise in the coming decades is a question. But the main point that really interrupts them is the human or built environment. And so I think we as a state and decision makers across all levels within the state really need to sit with that, really think critically about what we can do in the management of our human environment and our built environment to try and restore and maximize and enhance our coastal habitats for the public and for the many benefits that they provide to our communities, including including recreation and opportunities like that.
Great. Thanks so much, Walter, and thanks to you as well, Alyssa, for joining us today for this learning session. And hopefully everyone on the line found this as informative as I did. So as a reminder, the webinar recording and the PowerPoint presentation will be shared by email and will also be posted on the ARCCA website. If you have any additional questions for either of our speakers, we'll make sure we include contact information as part of the follow-up email. Just a quick plug for folks, for all of you who are working on adaptation. Hopefully we'll see you next week at the California Adaptation Forum. It'll be held August 27th to 29th in downtown Sacramento, and you can learn more at californiaadaptationforum.org. And with that, that concludes this webinar. Thank you everyone for joining us today.